In this question, an electric field of 20 Newton per Coulomb exists along the x-axis in a space. Calculate the potential difference VB minus VA along the points A and B. So here we have three coordinates given A, B and C. So separately we have to find the potential difference of each of the coordinate. So let's look into the first one. So here we know that electric field is acting along the x-axis. So here is our y-axis and this is the x-axis. An electric field is acting along the x-axis. Its magnitude is 20 Newton per Coulomb. So in this case, we have two coordinates. A is at the origin 0, 0 and B is 4, 2 meter. So here we will use the formula V is equal to minus E dot dl, because electric field is along the x-axis. So we will take the coordinate of x-axis, means our coordinate is here 0 and 4. So V is equal to minus 0 to 4 20 into dx. V is equal to minus 20 into 4 minus 20 into 0. So V will come as minus 80 volt. Now in the B part, A is equal to 4, 2 and B is equal to 6, 5. So here if we substitute, this is A for the second case and B is 6, 5. Let's make here B 6, 5. So now in this part, we will again use the same formula. V is equal to minus E dot dl. So x-axis value is 4 and 6. So it will go from 4 to 6. E is equal to 20 into dx. V we can write it as minus 20 into 6 minus 20 into 4. V is equal to minus 120 plus 80. V is equal to minus 40 volt. Similarly, in third question, A is equal to 0, 0 and B is equal to 6, 5. Means this is the A for the third option and here is the B. So in this case, our x-axis is 0 for A and for B it is 6. So we can write it as V is equal to minus E dot dl from 0 to 6. V is equal to minus 20 into 6 minus 20 into 0. So V is equal to minus 120 volt. In the last question, here it is mentioned that do you find any relation between the answer of part A, B and C. So as you see, answer of A is minus 80 volt and B is minus 40 volt and C is 120 volt. It means that voltage of C is equal to the sum of the voltage of A plus voltage of B. So this is the relation. That's it in this question.